This time I want to go to page 36 and look at some of these more horrific ones with a little yellow asterisk by them. These are the nth term for non-linear linear sequences. In other words, it may have an x squared in it, an x cubed in it, or something worse. So let's just try one, shall we? Oh, that's Sammy's song, by the way. Now, question 10. Look at the first one. I've got 1, 4, 9, 16. Now look at them very carefully. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So really it's a sequence of square numbers. So the rule is, what is the nth term going to be? Very simple, n squared. So that's the rule for that sequence there. Look at the next one. Work down here. It goes 2, 5, 10, 17. Now look, it links very closely to the 1, 4, 9, 16. Can you see that each one of these is one more than the sequence that was above it? So if the first sequence here is n squared and each one of these is one more than n squared, then the rule has got to be n squared plus 1. And I think that is really neat because you don't have to go through all that suffering again. N squared plus 1, and that's really good. Let me try the next one. And if I write it underneath here, maybe we'll be able to see it more clearly. So here's the next one. It goes 2, 8, 18, 32. Remember, this one here, this rule right across there, is the n squared rule. This one is an n squared plus 1. Now this one, let's see how that relates to the original n squared. Look at that. That's twice as much as 1. 8 is twice as big as 4. 18 is twice as big as 9. And 32 is quite honestly, is twice as big as 16. So really I'm taking my n squared and I'm doubling it. I'm multiplying by 2. So the rule for this sequence here, 2, 8, 18, 32, is n squared doubled. In other words, 2n squared. And that's about as hard as it's going to get, I reckon, on the foundation paper. Anything else more tricky? Well, I'll do the next one on the other page. I really like this one. Here, look at this. 1, 8, 27, 64, 125. Now look, if your eye's not trained to recognise these, you can be looking for days and waste your whole hour trying to pass an exam and fail because you look at this all day. Look at it. Learn it from me. 1 cubed is 1. 1 times 1 times 1 is 1. 2 cubed is 8. 2 times 2 times 2 is 8. 3 cubed is 27. Why? Because 3 times 3 is 9, and times 3 again, 27. 4 cubed, well, 4 4s are 16, and 4 16s are 64. And finally, this is easy to see, 5 cubed is 125. 5 5s is 25, and 5 25s is 125. This is the good old n cubed rule, alright, not squared, n cubed. And look how quickly they get bigger and bigger and bigger. After 4 or 5 goes, we're in the hundreds, alright? Beautiful. And I want to leave that one alone. I'm not doing number 11. I will do number 12. I could have done a cut and paste on this one, but I'm going to draw a rough little diagram. I've got here some fences, alright? That's the bits that go across. And I've got 1, 2, 3, and that's the 2 bits that go across there. And then it goes 1, 2, 3, 4, and I've got all the bits of wood that go across there. And they've drawn this for you ever so pretty in the book. That's on page 36, question 12. And this is diagram number 1, that's diagram number 2, that's diagram number 3. And they've even counted the bits of wood. Oops, they've even counted the bits of wood for us. Let's just get rid of that. And 4 bits of wood for pattern number 1 or fence number 1. And I've got 7 bits of wood there. Look, 1, 2, 3, 4, 5, 6, 7. That's right. Here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, I may pick that as well. So look, then it asks us, how many pieces of wood will there be in diagram n? In other words, the nth term. How many bits of wood to work out the number that I need for any pattern number or any one along the sequence I'm about to ask you. So look, what's happening? 4 to 7, go up in 3s. 7 to 10, go up in 3s. Guess what? This is a definite 3n rule. Again, go back to the 0 term, pattern number 0, before we start building fences. What number add 3 makes 4? Answer 1. Final answer, 3n plus 1 is the sequence. Now look at it, let's just test it. Pattern number 3, or fence number 3, 3 times 3 makes 9. Can you see that? 9 plus 1 is 10, so that's correct. So that is the 3n plus 1, a very easy, straightforward, linear sequence rule. Derives straight from a little pattern. I'm sorry I didn't draw it all beautiful, but anyway, you can look it up on page 36, question 12. Having a quick look through the assess now, making sure there's anything decent in there. Nothing on page 37, doesn't touch grade C. Turning over the page, question 6 starts at grade C, so I'll do a couple from there and then I'll just call it a day on sequences. Right, I've got here question 6a on page 38. This is the assess, and find the nth term of the following sequences. Okay, nth term, here we go. 6, 8, 10, 12. 6, 8, 10, 12. I'm going to go quite quickly. What are we doing? Go up in twos. What are we doing? Add on 2. What are we doing? Add on 2. Tell me, it's a 2n rule. Back to the 0 term. What plus 2 makes 6? Answer 4. And 4 is a 0 term. 2n plus 4. Let's just test it out. Use a different flavour. Supposing I want to go 1, 2, 3, 4. I want to test the 4th term. I'm saying the 4th term is going to be 12. Well, what is 2 times 4? Let's go blue. 2 lots of 4. There you go, the 4th term. 2 lots of 4 is 8. Plus 4 makes 12. Got it right. So the 4th term is in fact 12. Dead easy. Doesn't ask me to test it, but you can always test it yourself. And if you're in an exam, you can check it out. If it works, you've got it right. If it doesn't work, you've got it wrong. So think again. Here's the next one. Working down here. 3, 13, 23. And then what happens? It says 3 again. I bet it's supposed to say 33. I'm going to write in a 33. I reckon that's a misprint in the book. Don't all those odd numbers scare you? They certainly scare me. But anyway, once you start saying plus 10 and plus 10, it's not scary anymore, because you know it's a 10n rule. What's my question to you? What number plus 10 makes 3? Answer, minus 7. Alright, so there's your 0 term. So minus 7 is the 0 term, therefore 10n minus 7 is one's answer. Let's just test it, just for if we're happy about it. Let's try the very first term itself, number 1. So the first term should give me an answer 3. Okay, well 10 times 1 is 10, and 10 take away 7 is 3. That works. Let's do another one. Let's put a 2 there. My second term should be 13. So scrub out that little one. Goodbye, you've gone. Right, what's 10 times 2? 20. What's 20 take away 7? 13. Yep, we're totally happy with that. That technique worked, didn't it? Totally happy with that. And I want to do question 7 actually. It's a little bit weird. This will be the last one, I think. It says the nth term of a sequence is this: 4n minus 5. And the nth term of a different sequence is this: 8 plus 2n. Joe says that there are no numbers that are in both sequences. Show that Joe is right. Well, look, if I convert this into a very small equation, if I was to convert this into a small equation like so, I know we're not going to do this until, you know, way further on in the course, but if I can get n as a whole number answer, then there are numbers that fit with both of the sequences. If I get an answer where n is, say, a fractional thing, you can't have a fractional member of the sequence. So, for example, we've got the first, the second, the third, the fourth, the fifth member, but you can't have member number 6.5 or member number 8 1/3. Okay, it's either number 8 or number 9, but not 8 and a bit. All right. So if I can solve this as a simple equation, then what I've got myself an answer which will work with both of these rules. And let's just take a look. Now, remember key stage 3, 4n. You see the plus 2n? You go over here and get subtracted. So 4n minus 2n equals 8. The 8 has not moved, and the minus 5 goes to the other side and becomes positive. Right? that's negative, that gets added to the other side, so that becomes plus 5. Altogether I've got 2n equals to 8 plus 5, that's 13, so my sequence number must be 13 divided by 2, which is number 6.5. Well, you can't have term number 6.5. You can have a 5, you can have a 6, you can have a 7, but you can't have a member which is 6.5 along from 0. So there you go, doesn't work. Not a whole number, so Joe was correct. That's that one then. I want to just sign off the sequences, and I'm happy just to leave that alone. The next chapter will be about fractions. Gulp.